Hi, this is Stephanie Slater, and you're listening to a recast of the December 2010 presentation given at the fall meeting of the American Geophysics Union in San Francisco, California, entitled Dreamers, Poets, Citizens, and Scientists, Motivations for Engaging in Galaxy Zoo Citizen Science. This work has been primarily conducted by myself, Trent Mankowski, a graduate student at the University of Wyoming, and Timothy Slater, the Endowed Chair of Excellence in Science Education at the University of Wyoming. And we're all three researchers for the Center for Astronomy and Physics Education Research, also known as the CAPER team. So we were happy to give this talk in the context of a larger citizen science forum. It was an honor to be included among so many people who are generating excellent citizen science projects for the population. And rather than being one of those people who was presenting a really cool project, we found ourselves being the cognitive scientists in the room who were trying to describe actually what's going on. A very different position, and the audience was very friendly to us. So I hope this talk is useful and that it provides information for citizen science projects as they move forward in trying to engage the general population in their work. So, citizen science is really hot right now. You can tell that because there's an entire day of education sessions at this meeting of AGU devoted to citizen science projects. When we were looking at what's going on inside of these citizen science projects and why people are participating in them, we could have looked at lots of really, really cool projects, and we hope we haven't offended anyone by choosing to look at this one. Project Budburst, the SETI project, the project on air quality, they're all really wonderful. But in trying to discern what's going on inside of the minds of the people who are engaging in citizen science, we fell back to our old physics roots, which was whenever looking at some kind of phenomenon, it's really smart to look at its critical points, look at its extreme points too, like 0 and infinity. For us, we decided that 0 would really be quite boring to look at because the odds of a project having 0 participation and telling us something meaningful was pretty low. And we can't quite get to infinity, but we decided we'd go to the closest thing we could, which is the Galaxy Zoo project, an extraordinarily successful citizen science project, and we feel like it's taught us quite a bit. So here it is. For those of you not familiar with Galaxy Zoo, and I imagine that's not too many people in the room or too many people listening to this recast, Galaxy Zoo is a project that was spawned by the need of scientists to categorize, classify, identify, describe a million galaxy objects. Now, it turns out that a million objects would be far too many for the scientists who are behind Galaxy Zoo to interpret on their own. And it turns out also that asking a computer to do this task is not very useful because a computer can only do what it's been told to do. It can only classify the images to the extent that you can put in the right parameters. And if an image comes up that doesn't quite fit those parameters, the computer obviously doesn't know what to do with it. Turns out that people are a lot better at doing this than the computers are, not only because we're great at looking for patterns, but because we have the ability to manage ambiguity. And collectively, if you have a whole bunch of people identifying the same object, those sort of ambiguous objects will fall out, and the scientists behind the project can spend their time looking at those kind of more difficult images. The way this project was structured is fantastic. Many people are not experts at categorizing galaxies, so the project starts off with a tutorial, and you can see a screenshot of that on the slide. The tutorial has the participants walk through practicing many different kinds of classifications. So, for instance, in this first one that you might see on the screen, there are 2 images of galaxies, and the first question that participants are asked to grapple with is this a spiral or is this an elliptical galaxy? When the participants go through and they're able to successfully classify or categorize multiple images, then they're sort of given license to pass on to the next level. When they get through all levels of the tutorial, then they're allowed to go into the database where they're actually categorizing or classifying the images of the galaxies, and that data is used for the actual science. Now, when when the citizen scientists look at each image, they're asked to do multiple classifications. So, for instance, in Galaxy Zoo 1, is it spiral or is it elliptical? Okay, well, if it's spiral, is it spinning counterclockwise or is it spinning clockwise? If it's elliptical, well, then maybe you don't have an extra question. But there's several things that go on, and in fact they're asked, is this a galaxy at all? Or is it a star? Or is it a satellite streak across the screen? Several things on each image. And there's somewhere near, I don't know, something like 1 million images in this database again. You would think that a few people would be interested in doing this, but as it turned out, this project went hog wild, like wildfire anyway. At this time, there's about 200,000 participants in the project, citizen scientist participants. It's hard to know exactly how many that should be because it depends upon who you get your number from, and it depends upon what day it is, and it's also internet, so it's a bit of a moving target. But I feel pretty safe in saying about 200,000 participants, and they did their job. That first year, they made over 50 million classifications, which if you're looking at something like 1 million images, means that each one of those images has been looked at multiple times. At one of the peak points in the program, there were 60,000 classifications made in an hour. So we wanted to know what exactly is going on inside the minds of the people who are engaging in this way, because there's little in our past experience to explain this kind of extremely exuberant response by the participants. So, what to do about that? How to figure it out? Well, the first thing to do, of course, first thing one might do is to just say, what's going on here? And in fact, we weren't the first people to do this. If we look at the screen, you'll see a screen capture of a post that was made by Zookeeper Kate, in which she asked, in which she said, "We've been overwhelmed by the response. We feel like we've really captured your imagination, and we'd like to know why. Please tell us why you're taking part, and we hope that we can learn from you, and that will be helpful in future projects like ours." You can see by looking at the data there that it's like, less than an hour from the time that Zookeeper Kate put in her post, her question, till Bunny BB responded. And there were lots and lots and lots of responses. The data set that we looked at contained over 1,400 responses to this prompt, and within those responses, participants responding to each other. We didn't look at all of that data because by the time we got through, let's say, 800 of them, we started to reach what's called theoretical saturation, and we pretty much knew what was going on, and we really didn't need to continue looking at all of them, although we did skim them. We didn't subject them to close scrutiny. So it turns out, like I said, that we weren't the first people to look at this data. There was a previous analysis that was done in which the researchers started off by creating an interview protocol and contacting a subset of participants in Galaxy Zoo and interviewing them with this prescriptive protocol. It was it was what in the research community we'd call a highly structured interview protocol. From those interviews, they went through and engaged in the coding and categorization of the data and came up with a set of motivations that you see on the right-hand side of the screen. The motivations that they found for participants included astronomy, contribute, fun, science, zoo. I'm not sure exactly what zoo means other than it being the title of the Galaxy Zoo. I'm not sure what's going on there. But anyway, after they got done categorizing these motivations, they did an ex post facto forum analysis, which is a fancy way of saying that they went back and analyzed pre-existing data. And what they were looking for was any sign that there were additional motivations other than the list that you see here. And they did that using frequency count. For us in cognitive science, we think that this is a really good introduction, a really good first stab at taking a look at what's going on inside of this phenomena. However, we feel like it lacks explanatory power. Some of the motivations, for instance, should not come as a surprise to any of us. We should not be surprised that the term astronomy pops a lot as we're looking through the data, because it is, after all, an astronomy project. We shouldn't see that the word science pops a lot because, again, it's a science project. It also doesn't help us move forward, because if we were to try to take these learnings and transfer them over to something, let's say, something like Sandra Henderson's Budburst project, the term astronomy really doesn't help. The term fun doesn't help, because fun looks like a lot of things to a lot of different people. So exactly how are we creating that fun? Learning is not particularly helpful to us as we try to move forward, because we don't know what they're learning or how they're learning it. So we wanted to find something that had a little bit more explanatory power that would be generalizable and that could help other projects as they move forward. So we decided to take another stab at it, again thanking them for the data that they provided for us and taking this first go. So we decided to take another stab at it using an interpretive research method. What does that mean? For those of you who are geologists and astronomers in the room, what exactly is an interpretive research method? Well, an interpretive research method is something that we use in sociology. It's a look for the meaning of it all, as Erickson would say. We're not just looking to describe what's going on, we're looking at what those events mean. And particularly, in the tradition of Dewey, we're looking to situate those meanings within the continuum of participants' lives. None of these participants came into Galaxy Zoo as blank slates. They all had a load of previous experiences. They had personal lives, they had work lives, they had childhood memories. They bring all of that with them into the Galaxy Zoo world. And after Galaxy Zoo, they walk out into the world with Galaxy Zoo as this new experience. So how does Galaxy Zoo fit into all of that? And the way we chose to go at this is grounded theory. So grounded theory is where one is trying to generate theory that is grounded in the data. We joke about it when we say that we don't know what's going on in a situation, so we try to create a theory from the ground up. But truly it means that the theory is grounded in that data. To be technical, what we're trying to generate here is maybe a theory or maybe an abstract analytical schema of the phenomenon, which means that we've taken the phenomenon and we've distilled it down past the individual details of it to try to create an explanatory model of what's going on here. And particularly in grounded theory, we focus on the interactions between people. We focus on social processes, say in this case, between the Galaxy Zoo structure and the participants. So we went in there and we wanted to see what we could find. But first, we thought we'd cheat a little bit, because that kind of work, that kind of coding and recoding and search for meaning is extraordinarily labor intensive. So we thought we'd take a little stab at it using a piece of software that might help us out. And we started out by doing a Lexamancer analysis. So Lexamancer is a fantastic piece of software created by the Australians. They're particularly good at creating research tools for qualitative analysis. And it produces a variety of representations of the data that you pump into it. In this case, the data that we pumped in was the blog posts by all the participants, taking out things like dates and times and their names and things like that, because those things don't matter in this analysis. We could show you that data or the results of that analysis in lots of different ways, but we really feel like this image that's on the screen here sort of encapsulates our experience with Lexamancer and the Galaxy Zoo data. What we see here is basically something that looks a lot like the previous quantitative analysis that was done. We see a host of words, many of those words related to astronomy. The size of the bubble kind of is an illustration of the magnitude of the signal coming off of that word within the data. And the relationship that you see between the bubbles indicates something about the relationship of the words and the way they're used within the data set. So when we look at this, again, it's not particularly helpful. We see the word fun, okay? And we see the word stars, we see galaxies. We should expect this, especially with stars and galaxies. We would not expect to look at a Galaxy Zoo blog and see that a term like NASCAR or wildflowers is popping up a lot. That would be nonsensical, because this is an astronomy project. We should not be surprised by galaxies, stars, and astronomy and sky rising to the surface time and time again. However, it doesn't really help us to understand what's going on inside the participants' minds. So when we look at this kind of analysis, we view it not as evidence, but as data. And it's not data that we can really transform into the kind of theory that we're hoping to be able to construct. So I bet you'd like to know what we did find. Unfortunately, because this is on YouTube and not in a lecture hall, I was able to slow down my speech to normal speed and also fill in some more details and more examples than I was able to do there. And it's taken longer than YouTube will allow me to put up in one piece. In order to find out what we did find, you're going to have to go take a look at part 2 of this presentation. Thank you.